So let's do problem number 3, which is really a difficult problem to set up from the relative velocity problems worksheet. And here's problem 3 right here. It says a navigator wishes to direct his aircraft due north. That means he wants that airplane to fly due north. The aircraft has an airspeed of 40 meters per second. If a strong wind is blowing 20 meters per second to the west, what must be the direction the navigator must point the airplane? So what direction you have to point the airplane, and what is your heading, and then what is the aircraft's ground speed? Okay, so here's what I'm going to do. I'm going to set this up with given. Based on this, what do we know? Well, I'm gonna say this is north, south, east, west, and I'm going to express each vector like the velocity of the plane equals. Now look, I'm going to do this in polar coordinates. A navigator wishes to direct his aircraft due north. So that means we want the velocity of the plane to be due north. Well, what direction is due north? That's 90 degrees. Okay? But we don't know how fast the plane is actually going to be going. That's what we want to try to find. And then it says the aircraft has an airspeed of 40 meters per second. So this is the velocity of the plane compared to the air. Some of you were using W for wind, and that's fine. You can use whatever subscripts you want as long as you know what you're talking about. Now, all we know is that this is 40 meters per second. But we don't know what direction this is. Just like we don't know what the velocity of my plane is, my ground speed, the actual velocity of my plane is, we also don't know what the direction is that I should point the airplane in the wind. Now we have only one other thing, and that's the velocity of the air. It says the velocity of the air is 20 meters per second to the west. Well, we know what that direction is. That's 180 degrees. Okay. And what are we trying to find? Well, it says, what must be the direction the navigator points the plane? That's this. And then, what is the aircraft's ground speed? How fast are they going compared to the ground? Oh, thank you. There we go. Let's zoom out. So, setting up this problem is the hardest part, actually. Because once you set it up and you understand how all the pieces fit together, then it becomes a very easy problem to do. Solve. Well, when I'm dealing with the relative velocity problem, I always go the velocity of the plane is equal to the velocity of the plane compared to the air plus the velocity of the air. I'm going to add these two together to get this. Well, I know what my answer is. That is, I know it's 90 degrees. So I'm going to draw a picture of this. See? So the velocity of the plane is going 90 degrees. So there's the velocity of the plane. Now I don't know how long this arrow is, but I do know that it's pointed to the north, straight up, 90 degrees. And then I'm going to add these two together. Well, I know that the velocity of the air is 20 meters per second at 180 degrees, or to the left, or to the west. And I'm going to add that to this, so I know this is where it's going to end. So I know this is going to be 20 meters per second. This is the velocity of the air. And I know that I'm going to go this plus this, so I have to hook these up head to tail. So this is the velocity of the plane compared to the air. And I know that this is 40 meters per second, but I don't know what direction it's in. I just know it. I have to point into the wind so that the wind will push me back on course so that I can fly straight up. Okay? So now I've drawn a picture of this, and I've used vector addition to do it. And I didn't really use the vector addition, when we were cranking out those problems, but I used it as in drawing a picture. Like these two have to be hooked up head to tail right here, and that the velocity of the plane, which is my result, starts where the first one started, ends where the second one ends. Okay? Well, now I can get the angles here, and I can get this magnitude, because I can see from this makes a right triangle, because this is north and this is west. They're 90 degrees apart. So now I can just go to right triangle math and say the velocity of the plane squared plus the velocity of the air squared equals the velocity of the plane compared to the air squared. That is, these make a right triangle. And so then I can just solve for the velocity of the plane equal to the square root of the velocity of the plane compared to the air squared, which is 40. Start over. This is going to be equal to this squared minus this one. And take the square root. So what is this? What is it? 34.6 meters per second. Then I look at my picture. Does that make sense? Yeah. Because look, the hypotenuse is 40, so this is less than 40. And it's on the right scale. Okay, it's going to be bigger than 20, but less than 40, and there you go. Now to figure out the angle, let's figure out what this angle is. And this angle is equal, well, what do I know? I know the opposite, and I know the hypotenuse. I also know the adjacent. So yeah, I can use inverse tangent if I want. But here I'm going to use inverse sine. No, I can't go off screen. So the inverse sine of the opposite over the hypotenuse well, this is the inverse sine of 0.5. That is, the sine of what angle is equal to 1/2? Well, that's 30 degrees. So that means that this angle here is 30 degrees. So I can say that the velocity of the plane compared to the air is 30 degrees west of east of north. Or I can say in polar coordinates that if this is 30, then this would be 60, right? Because it has to add up to 90. So I can say that in polar coordinates, this theta really, this theta of the plane compared to the air is equal to 90 minus the 30 degrees. So that's 60 degrees. So this is the angle I wanted, and this is the magnitude I wanted. So I know, okay, so in order to fly this airplane, in order for this airplane to go due north, has to point into the wind at an angle of 60 degrees right here. And although the airplane is flying through the air at 40 meters per second, compared to the ground, it's only going 34.6 meters per second. And this is something that pilots need to figure out if they're going to get from point A to point B in very windy conditions. Right? If you want to fly from here to Salt Lake City or something like that, and there's strong jet stream winds at high altitude, they have to figure out how to fly that plane. Now they have computers and stuff to do it now, but these are the calculations the computer has to make. Anyway, any questions? Hard problem. That is all.